right, well, welcome back. I'm going to go through some more integration with parts, a couple more examples. All right, so here we go. Integration with parts. First thing, we got to determine. All right, hopefully you watched my first lesson. But our key thing is we're breaking down functions that you see multiplied together. All right, and you can't use substitutions, so we're going to look at parts. Here we have x, secant of x, tangent of x. We have three different functions. If I were to try to use substitution, I don't know how I would use. Maybe secant, but then derivative secant tangent, that doesn't really help me out. I have this x just sitting here, so I'm kind of thinking, yeah, parts. Now, what do we use for parts? Well, first off, we got to take and look for our u. That's our first thing. After we find our u, I'm going to create a dv. All right, dv right here. So my u, I'm going to use this acronym to help me pick out u. All right, log, inverse, algebra, trig, exponential. So light or little integrals always taste excellent. Something weird, just helps you remember. All right, u. What we got here is don't have a log, don't have an inverse trig. I do have an algebraic expression. Here's the beta that right there. So I'm going to use x. That what's left over, hopefully this works out. I'm going to make whatever left over, whatever that is, even these two functions, I'm going to make it a dv. And it happens to be trig. And it happens to be secant tangent. Oh, that's cool. Because we are now going to use the magic 7. So before we do that, we have to figure out what is du. Well, that's going to be 1. We got to figure out what is v. All right, and what is v? We have this right here. In doing so, we're going to have, that's going to integrate into secant of x, secant of x. All right, so if we integrate this with secant of x, what we're going to do is we're going to do another magic 7 routine. All right, that's magic 7. All right, that's what I call it. All right, that's students remember usually. All right, we have, first off, u times v. So that's why we do the 7. U times v, x times secant of x. We're going to then minus the integral. All right, v times du. So finish up the 7. We're going to have secant of x right there, my friends. All right, and then we're going to have dx. Now from here, and now we got to figure out what the integral of secant is. Now, an integral of secant, many of you maybe will just be able to look this up on the internet. Probably going to look this up then too. But if you want to figure out secant, there's a little trick, all right? And we can use a little u substitution here. If we have this, I'm going to change a different color. Let's go with purple. All right, and figure out the integral of secant. This part is pretty basic. All right, what we're going to do is we're going to break this in. We're going to have secant of x, and we're going to take this times secant of x plus tangent of x. All right, and here is one way just to kind of help you figure out what is this going to be. So we have tangent of x. So what we can do is we can multiply that because that is 1. All right, when we distribute this through, we're going to have secant of x squared, all right, plus tangent, all right, of x times secant of x, okay, times tangent secant of x. All right, and then on the bottom, we're going to have secant of x plus tangent of x. All right. Now I remember, how do you ever figure that out? Secant x plus tangent x over secant x plus tangent x. Well, it's a little trick in math. Multiply by 1. And when we have this, there are several what you're doing with trig. You use different identities or whatnot. We can use these. So this is just one of those extra tricks that we're going to do. All right, and that's how we can figure that out. Now, once you have that, what we're going to do is from here, I'm going to pick a u. So now actually we're using parts, but we're actually using u substitution. Now don't forget about this right here, just so you know. I'm not forgetting about it. I'm just worried about secant right now. I'm just trying to finish this off. So what we're going to do is we're going to pick a u. U I'm going to use is going to be secant of x plus tangent of x. And du then is going to equal, well, I'll take the derivative secant, which is secant x tangent x, plus now the derivative tangent, which is secant squared of x, and we're going to have dx right here. I'm running out of room. All right, got to move all this stuff over here. All right, let's move this over there. All right, now we'll go back here. All right, we're going to have dx. Oops, where's my green? There we go. We're going to have dx right there. All right, we have dx right there. Okay. Well, if you notice right here, u goes on the bottom. This right here is going to be du on top. And so using u substitution, we can finish up this problem. All right. to extend my page a little bit because I need more room. All right. And what we have then is the integral. Oh, my line. There we go. We have the integral of du over u. And I'm just going to bring down the other one. And that's going to be minus, all right, x secant of x. And what's the antiderivative of 1 over u? Well, hopefully you know that's the natural log. And we'll have natural log of u. Well, what's the natural log of u? Well, u is secant of x plus tangent of x. Equals the absolute value. And we're going to go plus c, bada bing, bada laboom, and x secant of x. And there we have it. Like butter. All right, this one's a little bit harder, but yet still all the principle of use of our parts works. We see two multiplication, we find our u, we then take our dv, we use the magic 7, u times v times du. When we set that up, remember your integral, we get the integral secant. A little bit trickier. We have to solve this unless you just memorized it, what that antiderivative is. But when we have this right here, we can use substitution. There are other ways of solving that, but I use substitution here. Find this out, and we have our answer. All right. I hope this helps you out. I'm going to go through some other examples, but this one's a little bit longer. So if you want to check out some other tutorials on some other parts problems, go right ahead. All right. Good luck and God bless the rest of your